Welcome to another Prince George's County Memorial Library System STEM at Home presentation. Grace Hopper and Code Debugging. Hello, I'm Bob from the staff at the Greenbelt Branch Library. Today I'm going to provide some information about Grace Murray Hopper, who was a computing pioneer. Some of you may know her as the Queen of Computer Code, who developed the process of debugging code among many of her accomplishments. Later, we will practice debugging some code of our own by visiting the code.org website. Grace liked to discover how things worked. At age 7, she took apart an alarm clock, studied the parts, and put it back together. She grew up at a time of unusual opportunity for women, as society supported their interest in higher education. Grace earned a master's degree in 1930 and a PhD in 1934 in mathematics from Yale. Grace was eager to join the military during World War II, but they rejected her several times due to her age and small size. Finally, in 1943, she joined the U.S. Naval Reserve WAVES, Women Accepted for Voluntary Emergency Service. The Navy Bureau of Ordnance Computation Project sent Grace to Harvard to work on the first computer in the United States, the Mark I. At that time, the computer was new to everyone, so Grace was tasked with writing the first computer manual. Here is a picture of Grace along with her co-workers in front of just a portion of the Mark I computer. She participated in the development of the Mark II and Mark III computers. While working on the Mark II computer, Grace and her co-workers could not understand why it stopped working, so they took the machine apart and found a large moth blocking a relay. From this experience, Grace was the first to call a computer problem a bug and to then debug a computer. The Smithsonian Institution National Museum of American History collection includes the logbook where Grace recorded her encounter with the moth. She actually attached the remains of the moth to the entry in her logbook. In 1949, Grace left active military service to work on the UNIVAC I commercial computer, but she remained a member of the U.S. Naval Reserve. Grace developed the A0 Arithmetic Language Version 0 as a compiler system that would convert one programming language into another for the UNIVAC. Compilers eventually made it possible to write programs for multiple computers rather than a single machine. Next, her team developed Flowmatic, the first programming language to use English-like commands. Grace realized that data entry tasks would be easier to complete with fewer errors by using words instead of mathematical symbols. Here are some photographs of Grace Hopper working at the UNIVAC I computer obtained from the Computer History Museum archive. In 1959, Grace led the team that introduced COBOL, Common Business-Oriented Language, to the computing world. It was adopted by the Department of Defense and became the first standardized general business computer language during the 1960s. From the 1960s to the 1980s, Grace continued to serve in the Naval Reserve. In 1966, she retired from the military, only to be reactivated to serve again a few months later. She was later promoted to Rear Admiral in 1983. Grace serves as an inspiration to modern coders for her efforts to simplify programming to allow it to function uniformly across many computing platforms. While a student, I was introduced to the remarkable Grace Hopper via a CBS 60 Minutes interview broadcast in 1983 before her promotion to Rear Admiral. In fact, it was this interview that inspired Congress to pass legislation requesting her advancement in rank. As a person who had some limited experience coding by that time, it was fascinating to learn her story. Although CBS has posted a portion of that interview on YouTube at the link shown here, we do not have permission to show it to you now as part of this program, but I encourage all viewers to look at it afterwards. During the 60 Minutes interview, Grace pointed out that the computer technology revolution was only in the beginning stages in 1983, the Model T era. She demonstrated the difference between a nanosecond and a microsecond as it relates to the travel of electricity, a fundamental component of computers. Grace amazingly predicted that the scope of changes to come in the next decades would be greater than the advances of the first 40 years. To demonstrate how forward-thinking Grace was in 1983, I thought I'd list some of the breakthroughs that have occurred since then. Personal computers with multi-core, multi-threaded processing units operating from 1 to almost 10 billion cycles per second, using mechanical and solid-state hard drives, and LCD and OLED monitors with flat and curved screens. The Mac, Windows, and Linux operating systems using graphical user interface. New programming languages such as C, C++, Java, JavaScript, Python, and Visual Basic, just to name a few. A vast array of computer programs, games, and applications, including Office suites like Microsoft Office, the Internet, World Wide Web, and various GUI web browsers, compact disc, digital video disc, and Blu-ray optical disc media and players, Wi-Fi and 3G, 4G, 5G mobile networks, smartphones and tablets, server farms and the cloud, instantaneous communication and streaming platforms, global positioning system navigation devices, self-driving vehicles, virtual and augmented reality devices and platforms, and artificial intelligence. Now we will visit code.org to practice some B debugging. So now we're in the beginning of the Debugging with the B lesson on code.org. And we'll start with the introductory video that provides some instructions.
Have you ever heard of debugging a program? This is the way you figure out what's not working. When you debug code, you identify and remove errors.
So here we're given a few blocks already in our workplace. We're going to use the step button to walk through the blocks step by step to see if this is the right solution and where we may need to fix it. Looks like there's our problem. We need one more move forward block. The step button helps us debug our program by identifying where the error is so we can fix it.
So here's our first puzzle in the B debugging lesson. Keep in mind that programming is really creating a set of instructions in a particular sequence. And so that's what we'll be doing in these puzzles. So right now the object is to collect nectar from the flower. And I should point out, because I had practiced this once, that by each flower is a number in the corner that indicates the quantity of nectar that's available. And that'll prove important as we move along into the later puzzles. So as the video demonstrated, we're going to see what happens with the beginning code here and see if that works and what might need to be changed. So we'll step through the process. So it looks like the problem might be is that you have to be on the flower to collect the nectar, and the forward block stopped right before the flower. So let's try to add another forward block in to see if that corrects things. So now that we've done that, click on reset and we'll step through it again. 2. And we were successful. So now we may move on to the second puzzle. Okay, well, while we're waiting for this, I should point out that I would think that Grace Hopper would particularly be impressed with this process of learning code. So now we'll step through this second example. And notice we now have 2 flowers, each with the number 1 in the corner. So step through, nectar, step through, get nectar. And it looked like that worked. So we'll click continue. Okay, so now we have 2 flowers. They're spaced apart, each with a number 1. So let's see what happens again when we use the beginning code. So forward, get nectar, turn right, move forward, turn right, move forward, get nectar. Whoops. Seems to be that the bee went in the wrong direction. And that seemed to happen when we got to this block here. It turn right. I think he needs to turn the other way. So let's change that to turn left. And we'll reset and try the code again. Okay, so far so good. Now we're going to turn left, forward. And there we go. So now we're ready for puzzle 4. Okay, so main difference here is the 1 flower now has the number 2 in the corner. So let's see what happens with this code. Move forward, turn left, move forward, get nectar, turn left, move forward. Oh, there's a few problems there, I think. So let's see. When we were on this flower, we only got nectar once, but the number was 2 when we started. So I believe we need to add another get nectar into our code. And then again, there seemed to be a wrong turn. So Let's change that to right. And let's see what happens this time. We'll reset things. Okay, here we go. And we got it that time. Okay, now this next puzzle introduces a new concept, and that is, what I know in coding they may refer to as subroutine. Instead of having to reuse the same code, and put it in each time, instead you can take and insert that into the subroutine and just tell it to do the subroutine multiple times. So that's what's happening right here. It's saying move forward 5 times and then get nectar. So I'm just going to click on run right now and see what happens. So it looks like it was too many steps. And instead of 5 times, maybe it should only be 4. So let's reset it and we'll tell it to run. See what happens. And that made the difference. And this is a good example of how the real world of coding works. A lot of times your first attempt may not be fully successful. And so it's a matter of trial and error. And debugging is trying to find, where the errors are in your code and correcting them. And it may take multiple attempts until you get it to run, perfectly the way it was intended. So now we're telling the bee to move forward 3 times, turn right, move forward 5 times, and get nectar. So let's see if that works. And so it did. So now we'll move on to the next puzzle. Okay. Now things are getting tricky. And before we try to fix this code, I wanted to point out something. When you go back and try this on your own, you may get stuck. And if you do, they offer this link here that says see a solution. If you click on that, it'll offer you suggestions of how you might structure your code to get to the goal. So let's see what happens with this code right now. I'm telling it to move forward twice and then 4 times to get nectar and then 4 times to get honey. So let me run it. So there seems to be multiple problems here. To start with, the number in the corner for both the flower and the honeycomb was 5. So I believe we need to change these 4s to 5s. Okay. But the other thing is that you have to be on the flower for the get nectar function to work, and you have to be on the honeycombs for the make honey. But the code right now isn't telling the bee to move from the flower to the honeycomb. So it looks like we need to add a move forward, and it needs to be between these two subroutines. So let's give that a try. And there we go. We made it through puzzle number 7. So now if you wondered why I keep clicking on start over, it's because I had gone through all these puzzles once before and it remembers that. So I'm trying to set it back to the way it was originally. So now this code says to repeat the routine of moving forward 3 times and getting nectar. I think that's a little strange because if you move forward 3 times, it looks like you're gonna be already on the last flower. And notice each flower only has the number 1, so you only need to get nectar from each flower once. I'm gonna go ahead and run it just to see if there's a problem, and there certainly was. So the problem is it looks like there's too many forwards in this subroutine, because really it should be move forward, get nectar, move forward, get nectar, move forward, get nectar. So we need to take out the extra move forward blocks from the routine. So I see I managed to grab the get nectar when I did that. So we can just pull the get nectar back and put it back in the subroutine. If it cooperates. And we went to forward before the nectar. There we go. So now I think we're telling it to do the same action 3 times. And that should get us to our goal. So let's reset and run. And see, it worked. So on to the next puzzle. And it looks like we have to wait a little bit. But here it is. I'm gonna reset it again. Okay, so this time we have 3 flowers and 3 honeycombs. Each one's got the number 1 in the corner. So we only have to use the get nectar and the make honey once on each flower or honeycomb. So let's see what we have here in the formula. It says repeat 3 times, move forward, make honey, then turn left, and repeat 4 times, move forward and make honey. Well, we only need to make honey when we have the honeycombs. And so that makes sense in the last subroutine, but not in the first subroutine. I think we need to take out that make honey. And let's put a get nectar there. Come on. And there we go. So again, we have the subroutine of move forward, get nectar. Now, after we're done with the flowers, again, we do need to turn so we can go up, but there's only 3 flowers. So I believe we need to change that 4 to a 3. So let's give it a try now. and we were successful again. So now we'll move on to the next puzzle, number 10. So now we have quite a number of flowers and honeycombs. Now, again, each one only has the number 1 by it. So we only have to do each action once on each flower and honeycomb. So now it's a matter of starting to count things. I'm going to click start over just so we can start with the original concept. So it says 3 times, move forward, get nectar. So I think that would work. And then yes, we have to turn. So it says turn right. And then we're going to move forward and get nectar some more. And then turn again. It says 1, 2, 3, 4, 5. And move forward and make honey. I think there may be a problem here, but let's run it and see what happens. So we only got honey from that last honeycomb. And I think that's because the make honey needs to be part of this last subroutine so that we get each honeycomb. So we changed the subroutine to move forward and make honey. So let's give that a try. And there we go. So we completed puzzle number 10, and I believe we have the final puzzle for this lesson. And let's see what we get. Okay, so we have 1 flower with the number 5 in the corner. So that means we need to get nectar 5 times from that flower. So to get there, we need to move forward 1, 2, 3, 4, and turn and move up 1. So let's see what the code says so far. Oh, it says repeat 3 times, turn, and then 5 times to get nectar. Let's see if that's really going to work. Looks like we got a couple problems because it didn't get into the right column to match up with the flower, and the bee looked like it turned the wrong direction. So I think that's because we need to change this 3 to a 4 and change the turn from right to left. So let's see if that change in code works this time. And there we go. So we completed the last puzzle. And so with that, we are done with the bee debugging. So again, you are welcome to give it a try on your own after this activity. And there are other debugging options available besides the bee debugging. As you can see, if you finish that lesson, it will take you to artist debugging if you're so interested. Before we end this presentation, I thought I'd share with you how you might be able to locate more information on Grace Hopper. The easiest thing would be to go to our catalog, and in the keyword search, type in the word Grace Hopper. You should discover about 25 items that are available. So I've identified a few items to show you out of that 25. The first is mathematician and computer scientist, Grace Hopper. Then there's Grace Hopper, Queen of Computer Code. And heroism begins with her. Inspiring stories of bold, brave, and gutsy women in the U.S. military includes a portion on Grace Hopper. And there's programmers with STEM projects for kids, which talks about Grace Hopper. Then She Did It, 21 Women Who Changed the Way We Think, Grace being one of those women. Girls Think of Everything, stories of ingenious inventions by women, again, which includes Grace. There's Little Dreamers, visionary women around the world. Good Night Stories for Rebel Girls, 100 Tales of Extraordinary Women. And Women in Science, 50 Fearless Pioneers Who Changed the World. So there's several options if you are interested in learning more about Grace. If you're interested in coding, you can do a keyword search in the catalog on coding. There are over 900 items in our catalog on that topic. But meanwhile, I just wanted to highlight some of the websites that I used to do some reference research on Grace Hopper. The third website listed here, Rediscover Grace Murray Hopper, is on the Arlington Public Library website, and that is because Grace spent the latter part of her life working near or in the Pentagon, and she chose to live in Pentagon City, which is in Arlington County. So Arlington is proud of that fact and highlights it on their library's website. Thank you for joining us today for this STEM activity about Grace Hopper and code debugging. We hope you found it both informative and interesting. The library invites you to join us for other virtual programs throughout the month and year. Our virtual events calendar is always available on our website at pgcmls.info. Please have a wonderful day. This concludes our program. Bye.